Hi, solve the given OD. You are given y double prime minus 2y plus y, which is equal to exponential negative x. So first of all, you are going to consider the complementary part, which will become y double prime minus 2y plus y is equal to 0. So to solve the complementary part, we shall write our y to be equal to exponential mx. Then we differentiate y once to get y prime as equal to m exponential mx, and we differentiate y second times to get y squared exponential mx. From there now we substitute our values of y here. Y double prime is m squared exponential mx minus 2. This is what 2y prime, sorry, this is y prime. 2m, y prime is m, so 2m substituting plus 1. We have factored exponential mx, this is equal to 0. Note that exponential power mx can never be equal to 0, meaning that our m squared minus 2m plus 1 is the one which is equal to 0. This is a quadratic equation which can be factorized as m minus 1, which is equal to 0, meaning that our m1 is equal to 1 and our m2 is equal to 1. So our solution for the complementary part becomes c1 plus c2x exponential x. On how we arrive at this solution, check in my channel. I have shown you why we write this solution in this form. When we have the root being equal and being real, equal, and repeated. That or the reason as to why we write the solution of this form. Now next, we are going to obtain the particular part, which is by the method which is called method of D operator. So we shall use method of D operator to obtain our particular part. So from here, yp is equal to exponential negative x divided by d squared minus 2d plus 1 using the fact that when you have yp, which is equal to exponential rx divided by f of d, this is the same as exponential rx over f of r. R is the constant. In our case here, our r is negative 1, so we shall have exponential negative x divided by negative 1 squared minus 2 into bracket negative 1 plus 1. That way, so which is equal to exponential negative x divided by, so negative 1 squared will give you 1, negative 2 times negative 1 will give you plus 2 plus 1, which is equal to y exponential negative x divided by 4. Now, our given OD was y double prime minus 2y prime plus y, which is equal to exponential negative x. So our complete solution, y, will be given by y complementary plus y particular, which is equal to c1 plus c2x into bracket exponential x plus 1 over 4 exponential negative x. So that is our solution of the given OD. So you can even try to check whether this is correct by differentiating this twice. So you can check. To check, you just differentiate this twice. I will just give you int. So here you have y prime is equal to exponential x into bracket c1 plus c2x. This is a product. Then you want plus exponential x c2 when you differentiate this part here with respect to x, you are going to get c2 when you differentiate it with respect to x. So yeah, it will give you that part. And because now you are holding exponential constant and you are differentiating the value with x, then minus 1/4 exponential negative x. Then you differentiate again y double prime, which is equal to exponential x into bracket c1 plus c2 x. Then you differentiate this again, which will give you plus c2 exponential x plus c2 exponential x plus 1/4 exponential negative x. That way, this is equal to exponential x into bracket c1 plus c2x plus 2 c2 exponential x plus 1/4 exponential negative x. Now you come and substitute them. So you come here and you substitute them in y double prime minus 2y prime plus y. You see whether you are going to get exponential negative x. So you can do that and let me know your feedback, the result which you obtain. Bye bye. Thanks so much for taking your time to study with me on how to obtain the solution of an linear second order difference equation with the constant coefficient. Thanks so much. If you find this video useful, kindly you can subscribe so that you may not miss a single video which I upload for us every day concerning maths and other field of study. Bye bye. See you in the next presentation.